Welcome back to Forward CloudSec. Before we begin, I'd like to thank our sponsor, Netflix. They just wanted to support this community and support this event, so thank you very much to them. Get back to our next talk, but first, especially for those of you following along on the live stream, there will be a Slack thread in the Forward CloudSec Slack channel. For you have questions, post them there, and we'll be monitoring it. So our next talk is From to Privilege Escalation, Finding Vulnerabilities from a Bug in the AWS Console with Ben Breitz.
Hello, everyone. Thanks for having me. So I'm here today. My name is Ben. Going to tell a story that has some bugs in them as examples. All of them have been fixed by now. So you don't have to open up your laptops to start trying to exploit them. They have been fixed. This is a story. This is how we found something that eventually led to a limited privilege escalation. But it's also asking a question of you, because I know that a lot of people here are either security researchers, but also people working for companies that are building SaaS products. And I want to use this story as a way to ask a question of you. And that is, if you're building something, and especially if it's a security feature, who are you building it for? And it will get more clear in a moment, because I'm actually going to tell a story that started with a question, where everyone was confused. And it was also because I'm not a security person. I work for a company called Cloudar. We're an AWS primary consulting partner. So we do everything AWS, from reselling, consulting, managed services. We help our customers be secure in the cloud or be happy in the cloud. And at some point, one of our customers came to us saying hey, you set up a directory service for us, and it's working perfectly, but we see some strange things. So a very quick primer on AWS Directory Service. Directory Service is an identity provider within your AWS account. So it is usually a managed Active Directory, but it can also be connected to your own directory, your Active Directory, either on EC2 or on premises or on another cloud. And there's also a lightweight LDAP-based version called SimpleAD. All of these you can configure within your account, or you can share between accounts. And then they can be used to connect to either your EC2, you can domain join them, or there's a lot of other AWS services that integrate with them, like Workdocs, Connect, things like that. The thing we're going to be looking at right now is how you can use that to also connect to the AWS Management Console. So you can use your identity inside of your Active Directory to actually assume a role inside of AWS. And this is what we were seeing. Everything was working, let's set this up, but looking in the console, it showed as disabled. So our client came to us saying hey, this is disabled, it is working, what is going on here? So what we did do, we double checked. So we went into their account, looked yes, we can test this. You can actually sign in, you get the interface, but you get the CloudTrail events. So for people not used to working with AWS, CloudTrail is the management event logs. It's everything that should be happening in your account. It's not all in there. If you watch Nick's talk from this before noon, there's a lot of things about CloudTrail in that as well. But we could see the assume role is working, but it still shows as disabled. What is going on here? So we started our investigation, trying to figure out what is happening. And what is the first thing you do as an operator? You look in CloudTrail. The same thing you do as a security person. It's what is happening here? We should be able to see everything in CloudTrail. Unfortunately, for people who can read very fast or have very good eyes, you don't see anything in CloudTrail, or we didn't see anything in CloudTrail at that point that was related to enabling, disabling directory service. So what's the next step? We look into documentation, what are the actions we actually should be seeing here? And we tried enabling, disabling the complete setup ourselves, so set up a new directory service in a test account. Looked in the documentation, there are a lot of different actions related to it, different permissions. And we can also see that there are some permissions that don't have an API with them. Which are, in this case, exactly the permissions and exactly the actions that you do when you enable and disable that integration with the management console. So we know that there was something strange here. There's missing data in CloudTrail. We reported this to AWS. This is solved by now. But we did learn some things from this. So first of all, like CloudTrail should be a given. It is not, which is interesting both from like a operational and defense perspective, but also from an offense perspective. And like having that data is incredibly valuable for everyone. Not just for security perspective and for sending it to your SIEM, but just me as an operational person trying to debug something, an application developer trying to debug something, being able to see like, this is the action I executed, and I can see it like arriving in CloudTrail, whether that's with an access denied or whether that's like actually successful, is very valuable information. So who are we building for here? Like who is CloudTrail meant for? And I would argue here that yes, CloudTrail is a security feature. It is built for security, but it's also built for everyone else. Like it is something that we need to be able to actually work with service in the cloud. So here we're going back to like my initial question to you, like if you're building something, please give me audit logging. This is something that is very frustrating for me. If like something works, everything is fine, and then something breaks, and I have to figure out, is it something we did? Is it something that the SaaS provider did? Is it something that AWS did? And audit logging is very helpful with that. So what do you do if you can't reproduce the issue? Then you turn on your research modus, and you open the AWS console and you look at what is AWS doing actually here. So if you look at the AWS console, like I'm going to repeat things that Nick said for people who were like in the previous session before noon. AWS console uses the AWS APIs internally. You can find which calls are more UI related and which ones are actually going to the service. In this case, everything going to directory services is ds.region.amazonaws.com. We can filter those out. We can take a look at them, and here's some interesting things you can see here. You can see that the user agent is the AWS JavaScript SDK, so they're using their own internal build of the JavaScript SDK that has more actions in them than the official public one. You can also see that they're calling a certain action, sending a certain payload. If you put it all together, you can actually translate that to the request that the CLI would be making, which is what you can see at the bottom. So actually, like, what would we like to do to test things out? Like, translate those requests we see in the console and create our own CLI for that. Luckily, it is fairly easy to do. Like there are, like Nick mentions, like those different protocols. You actually don't need to know about them. You need to be able to write a model file. The AWS CLI uses the Python SDK, which has all their models defined in JSON files. If you can create a JSON file like that, put that on the right place on your disk, which is defined here where that exactly is, you can have the AWS CLI do all the heavy lifting for you. So it will figure out the protocol, it will do the security version 4 signing, it will do all those things, give you the input and the output, everything like that. So you just have to create that JSON file. Which is what we did. So we created that JSON file and then just started playing with it. Started looking at like, what are the actual calls that we're making, what is actually happening. And at some point we discovered that if you use directory services at that particular day, if you enabled the management console integration and then did a list of the enabled applications, which is the top request here, you could see that there were 2 applications enabled instead of the only one you would expect. And what do you do if there's 2 things happening behind one button? Is you try to disable one of them. You basically create your own race condition here. And that is what we found. Like if we disabled only one of them, we would get the AWS console to show this is disabled, but the actual implementation would still work. This is something that we only could reproduce for a day. So by the time we reported this, it was already fixed. I'm assuming, never had confirmed, that this was a deployment in progress where they switched from one to the other, and that showed us some strange things inside of AWS. So what are some things we can take away from this? Race conditions will happen. It's not because something is non-public that it's unusable. You can use this like for attack purposes. Also, just like from an operational perspective, if you want to automate something that's not automatable, you can extract those things outside of it. And then you shouldn't class the client side, because I will just chase the request that I'm sending to you. Again, like, who are we building this for? And I think in this case, what are we building is documented public APIs. And I would argue that, again, that's something for everyone. Like, having those things undocumented might make you feel as a developer as like you have more flexibility, but also comes with some risks of things breaking things. People will expect things to work even if you don't document them. Like, APIs are forever. So again, here, like, those things are for everyone. And then finally, I promised privilege escalation. I haven't gotten there yet. So the thing that happened there is, like, we found like a race condition here. And then we got curious. So the next question is, like, what else can we do with those undocumented APIs? There are some others there. So we started to look at, like, okay, what's the different setups you can do, and how can you misuse this? So a typical setup might be you have your directory service. Those allow you to assume a role in AWS, and you can assign which group or which user can use which role. So a setup might be where you have, like, different owners managing that assignment for different groups. In an ideal world, and this is not how it's actually implemented, you would be able to say, Alice can manage group A, and I create a trust relationship from this specific user role, this specific role, to that specific group. So I have the assume role permission, or this the assume role trust policy is tied to that specific group within that specific domain in directory services, which is certainly not the case. So if you do the assume role, the trust relationship, what actually happens is only tied to the principal directory services and only sends the account ID and external ID. So we can't use that trust policy to define who can use a role. What we can do is we can do what every other service does and use the IAM IAM pass role permission. So instead of defining like you can manage this specific group, we have to give our users the permissions to manage the whole directory. And then we can give each user the right pass role permission, which is also what's documented, which is also what you would expect to work. And when we tested this, we found out that you actually didn't need the pass role permission. So pass role wasn't checked, which meant that you could do things like this. If you have access to manage one group, to assign a role to that group, you can assign another role that's not yours to that group as well. Or if you maybe don't even have your own domain, you can create a separate, maybe that simple AD domain, and reuse an existing role. There are some caveats here, like you need to have like fairly big or broadly scoped permissions within that AWS account. You can't go across AWS accounts, and you need a role to already exist with that specific trust relationship to directory services. And this has been fixed by now. Some things to take away from this. First of all, having non-public APIs makes it much harder to be secure. Like you could see that documentation page where it's like, hey, these are some other permissions that you might have to add to your policy. That is very hard. That is if you want to write a release privilege policy and you don't know which actions are going to be taken, which permissions you're going to need. It's going to be hard to write a release privilege policy. Similarly, like I think even some of them are not documented at all, but do have some permissions with them. It's just very hard, which lead to like the previous setups where you completely are relying on that IAM pass role permission to work. Secondly, external IDs. I can give a whole separate talk about external IDs, but this would also not have been a problem if the external ID that was used was not just the account, which is something that AWS should already enforce, that you can't pass a role between accounts. But if that was specifically tied to a domain within directory services or to even like a group or a role in that domain. And I think this is especially relevant if you're building a SaaS product where you're going to somebody else's AWS account. Think very hard about what your external ID is. Is it tied to like your tenant ID? Is it tied to within an AWS account within that tenant? Is it tied to a group within that tenant? Have that more specific will lead to a little bit of friction on the consumer side, but will also give a lot of flexibility in what you can put in that trust relationship, which is a much easier thing to manage than the IAM patch role permissions. And finally, verify the negative. Like, both if you're building something, but also in this case, if you're writing those policies, you're saying like, for me, it's very important that person X cannot access something that is created by person Y. You have to test that. Like, you can't rely on everything being bug-free. There will always be bugs. This was a relatively small one, like it's only one check that is missing. But if you're relying on that, you should make sure that it's actually not there. Which again, like, who are we building this for? And I think the IAM permissions part of this and the external role part is as much a security constraint or a security requirement as operational requirement. I want to have that documentation available when I'm setting up the service. This is not something that a security person is going to come back after me to say, hey, you gave too much permissions. So the harder it is for me to set that up correctly, the bigger gaps are going to be. And we all know that once you give somewhere very broad permissions, it's much harder to remove them than to add more permissions. So in conclusion, we can't have shared responsibility without having the right tools in place. This is CloudTrail, but this is also true for every SaaS product that you're building. If you want me to be able to manage users' permissions, things inside of an application, I need to have the tools for that. That is about logging, that is about configuration, is also about having the right APIs, supporting configuration as code, supporting infrastructure as code. All those things allow me to take on my side of the shared responsibility model. With everything else, like you can have like all these SOC 2 requirements and like ISO and like encrypt everything. But if I can't manage my users in your application, then that doesn't really matter. Secondly, there's still a lot of low-hanging fruit. Like directory services is an identity-based service. It is a relatively old service. And I'm not a security researcher and I could find a bug in it. This is something that I would expect if you're looking at things to break inside of AWS, looking at directory services, maybe Identity Center, Session Manager are all very interesting things to look at that can have a big impact, that all have non-public APIs. So I'm looking forward to see what somebody's talking to about next year when they're diving deep inside of those models. And finally, I've been asking this question. If you don't have an answer to this by now, then let me give me my answer. So first of all, security features are for everyone. If you're building it just for to satisfy your governance requirements or your compliance requirements, you're not thinking big enough. You should be thinking about operations. You should be thinking about developers. Make it easy for them. Removing friction there is also going to increase security. But if you need someone specific to build for, please build it for me. Add audit logs. Like sometimes, because I'm very much inside of the AWS ecosystem, and I sometimes forget when starting to look at other products that there's a lot of good things in there as well. Having CloudTrail available, having CloudFormation available, having all those APIs, give me a lot of tools. So please, if you're building something, look at building those tools inside of that as well. And I don't think these need to be fancy. Like with the new AWS Security Lake, there's like different formats that you can log into. Giving me an S3 bucket with like, here's just a bunch of actions that happened in your product will already like satisfy a lot of my requirements. Secondly, make your APIs public. APIs are forever. People are going to rely on them, and like you shouldn't take shortcuts because it's private. And I think Nick's talk is like a very good example of that. That everybody makes shortcuts, so it's going to be a balance. But think about like where you're actually taking those shortcuts and where it's important to have that documented and have that same rigor around everything. And finally, like use external IDs. Use them specifically. External IDs are much harder than you would expect. There's a lot of nuances there, but please think about them and think about how the minimum level of permissions or the most specific group you want to create in your application relates to the AWS accounts you're going to access and how that should relate to the external ID. Finally, there are a lot of places where you can learn more. There are other talks on this conference. So Nick Frechette talked this morning. There is a talk tomorrow that's more about how APIs evolve within AWS, which I think might be very interesting and related to this. There's Nick's API models, which is like all the things he could extract from the console. I have someone that I created manually. I think the big difference between those two is the ones that I created are directly usable inside of the AWS CLI. And I'm looking forward to someone who's like making the translation step of this is the JavaScript things, and this is the Python/CLI things that you can do with that. There is a talk from last year about AIM pastoral in particular, not about places where it wasn't present, but about places where it's actually present. And then finally, I wrote a blog post about this specific vulnerability, go into a bit more details, and also we found some other unrelated bugs inside of directory services that I invite you to read. It's at cloudart.be/AWS-blog/CloudSec2023. So with that, I have to thank you for your time. And if there are any questions, I will be here the whole day. Thank you.
Thanks, Ben. So one of our first questions in Slack, I thought was a very insightful one. One of your slides, you said that we can't claim shared responsibility without the right tools. Who, in your opinion, is responsible for building those tools?
That's a very good question. I think it's the provider that should build them. And also think it's not because I think you couldn't claim it that they're not going to argue that it's our responsibility to configure it correctly. But I think it's like part of that defense in depth strategy that we shouldn't just be configuring things right. We should also be checking that we have configured it right. And we can't do that without insight into like the back end of things.
And then one of your other kind of takeaways, you're talking about the pitfalls of it's hard to write IAM policies for undocumented API actions. Like, how do you think about defending against those kinds of threats that may come from these undocumented actions? How do we protect ourselves in that kind of world?
Yeah, I think in general, it's like AWS is never going to add more permissions to your own policies. So the first step is always like start with as little permissions as possible. And then whenever you need to add a certain permission that is related to an action that doesn't exist, I think we should just complain. Like there's actually like, I have to make sure I get it right. Don't just complain, like scroll down to the bottom of the documentation page. There's like a feedback button. Click that button and complain to AWS. And say them like, this is something that we need. And hopefully if enough people do that, we'll actually get more public APIs.
All right, well, thank you very much.
Thank you.